Hey folks, so this is Shetz and we're going to go over 9.4 notes and we'll follow along in your packet, handwritten 9.4. So, as always, I like to give you a little bit idea, prepare you. And if we think back to geometry, what kind of angle is this angle right in here? Whoops. That angle is what I want to know. It has a name. Well, guess what? It's a central angle. And what's the relationship between this central angle and this arc? Well, if you recall from geometry, the central angle equals the arc's measure. Okay, couple questions for you. What is the measure of A to B? Well, if you said the measure of arc AB is 90 degrees, you would be absolutely correct. Why? Well, this is coming from the center. This is a right angle. And if this right angle is 90, then this measure of the arc is 90. Okay, continuing on. Which arc has the longer measure, red or green? I'll give you a second. Well, they both measure 90 degrees, so they're actually the same. Now, listen to this question carefully. Which arc is longer in length, red or green? Well, I hope you've said the red, because as you can see, the red is a lot longer. Yes, they're both cutting off a 90-degree measure, but this arc is longer in length. Does anyone know why? Well, I hope you've said this circle is a lot bigger, so it has to travel longer as opposed to this here, the green. Okay. And we have our formula. S is the arc length, the length of the arc, is equal to the radius times theta. But wait, folks, in order to use this formula, we have to be speaking the radian language. And in the past, when we use radian language, I pretend that we live in France and you have to speak the French language. In America, we use degrees. In France, we have to use radian language. So make sure that theta is in radians. Just naming an angle, speaking an angle in a different language, in radians. In America, we speak it in degrees. In France, we'll pretend that we're speaking it in radians and using a different language. Continuing along with your notes, here we have a radius of circle. The circle is 3 inches, and the arc, the central angle, is pi over 6 radians. Well, they want to know the arc length. They want to know S. So all we have to do is plug in 3 for the radius and pi over 6 radians. Notice that reduces to pi over 2 inches. That is how long this red arc is. And that is an exact answer. Now, you know that pi keeps on going on and on and on forever. And if I would punch pi divided by 2 in the calculator, I would get 1.57 inches. Remember, this is an approximation. So instead of an equals, maybe I should have done these squiggly lines like that. 1.57 inches is the approximation. And you need to know what answer is exact and this answer is approximation. Anytime you have pi in your answer, that will be an exact answer. Because as we know, pi keeps on going on and on forever. So I just rounded it to 2 decimals. Okay. I would like you to just take a look at this. There's a lot of good things here. Let me do the sketch pad first. Whoops. Let me do the sketch pad first. Here's 30 degrees. These are all 30-degree reference angles. There's 45, 45, 45, 45, and now we go to the 60. Between the x-axis and this black terminal side is 60. Between this green terminal side and this x-axis is 60. Between the x-axis and the red terminal side is 60. Well, we know that half of, let me see if I can draw on this. I tried drawing earlier, but I can't. Well, that was almost there. So this whole is 180 plus 60 is 240. And I can show you that on the other one. And from the blue terminal side to this x-axis is 60. So starting in standard position all the way around to here to the blue would be 300, and then there's another 60. Let me go with that 241 and I'll show you that one. So as I was saying, all the way around here is 180 plus another 60 is 240. There's theta of 240, but this angle inside this little triangle is 60. 60 degrees more than 180 is 240. And if I keep that in radians, notice I have 4 pi over 3. So that leads us into the next question in our packet. The radius of a circle is 4 inches. Find the length of the intercepted arc. Well, they would like to know how long this red arc is, how long it is. We know that the central angle is 240. Well, before we do anything, let me move this guy down. Before we do anything, we must convert degrees to radians. Then we can use the formula. Well, up in 9.3, we learned how to get rid of degrees and change it to radians. So I can cross off the words, the degree marks. I can cross off the zeros. And if I take out a 6, I'm going to get a 4 over 3. So here's my 4 over 3, which is this work up here. I can now use my formula, plug everything into the formula. My radius is 4. Whoops, sorry about that. My radius is 4, and theta is 4 pi over 3 inches. That's this answer up here. And 4 times 4 is 16 pi inches over 3. And that is an exact answer because it has the pi in it. And if I wanted to change it to an approximation, and I better use those squiggly lines again. That's the symbol for approximation. It's a little hard to write with a mouse. And there we go. So if we had a circle that was 4 inches in a radius, and we traveled, we're looking for the length of 4 pi over 3, which is 240 degrees, this red length would be 16.75 inches. Okay, continuing on. Now they want to know the radius of the circle. Well, if the central angle is pi over 6, so let me label. This central angle is pi over 6. Pi is what? 180 degrees divided by 6 is 30. 180 divided by 6. Oh, that's a 30-degree angle. Pi over 6 radians. And the length of the arc is 2.46 inches. Okay. They want to know r. Well, in order to solve this equation right here for r, we would simply just divide by theta. And now I can simply plug everything in. S is 2.46 in red. That's how long that is in inches. We divide by theta, pi over 6, and dividing by a fraction is the same as multiplying by the reciprocal. And when you plug that into your calculator, you are going to get 4.70 inches. So this radius would be 4.70 inches. So that time we solved for r. The next question, we're going to be solving for theta. Find the measure of the central angle. We need to solve for that. Well, all we have to do, notice theta is being multiplied by r, so all we have to do is divide both sides by r, and we will get this equation. So we're solving for theta, divide by r, you get this. Well, it tells us that the arc length is 18. So from here all the way around to here is 18. We also know that the radius is 4.5 centimeters. Well, we have to plug everything into this formula. There you go. And 18 divided by 4.5 is 4. 4 what? 4 radians. And if you don't remember, let's go back to this. And again, this is day 1 of what is a radian. 1, 2, 3, 4. This is in the third quadrant. 4 radians. Remember, I asked you to know this counterclockwise as well as counterclockwise. 4 radians is down into the third quadrant. Okay. And, whoops, sorry about that. Let me change screens to... And remember, back when we were together, every day I was asking, here's a 45, 45, 90. What is x and y? And I always said the green numbers, root 2 over 2. And here's the short leg, and here's the long leg. What are those green numbers? Well, guess what, folks? We're going to have to start remembering these green numbers again, because that's what's coming up in our unit circle. So let me just see if there's anything else in our notes. That looks like that's the last question. I will give you a Google assignment, a Google quiz, and let me look at that for a second. I have it right here. So you are going to be doing 9.4, just this page, page 21, and also page 22. Now remember, in order to find this arc length, this has to be converted to radians, and then radians times the radius will give us this answer. There you go, folks. Hope you like it, and I will be providing you with a small Google quiz.